Welcome to another Taz Academy HVAC training video. Today's topic, troubleshooting sequence of operation failures through pictorial diagrams. I am your instructor, technical support manager and trainer for Total Air Supply, Randall Ripley. Total Air Supply is a Marcone company. In this three-part series final video, we will use sequence of operations failures to discuss possible causes and an electrical meter to troubleshoot possible electrical failures. Understanding the sequence of operations, basically the chronological order of events of how the equipment starts up, operates, and shuts down, is an important tool for the technician's toolbox. It helps you establish a reference point of where to start your troubleshooting if there is a failure during the sequence of events based on what the unit is doing and what it should be doing. And we see here in this little graphic here that we have 8 events that have to take place to get to where we need it to be running, operating. And we're stuck on number 3. So we have to ask ourselves, why am I stuck on number 3? What could cause this to happen? Because we need to get to 8. We're at 3. That's the question. What is it? And with furnaces, it could be water, an electrical issue of some kind, grounding. Grounding's huge. But you have to ask yourself what could cause that issue and rule it out. The sequence of operations can be found in the installation manual that comes with the G or AR9T96 R32 ready 2-stage non-communicating furnace. As we see here, our normal sequence of operations, talking about power up here, your continuous fan speed, your heating speed, and here you see that there's a couple others, FO1 and FO2 are the defaults for W1 and W2. But there are other options. And then we have heating mode, and it's just step by step, through this sequence of operations there. And this just shows some more of that, when the thermostat's satisfied, what's going to happen, because remember, the sequence of operations is the startup, the operation, the shutdown, and anything that happens in between going to second stage or something of that sort. And here we just see the second stage fire up, and we'll be talking about that in the video, but I just want you to see that's what we're looking at. And then you get an error code, an EEO in this case. That's a reference. You go to your troubleshooting chart with the diagram to see what it is. And then go to the troubleshooting chart, and we see that we look up here and we see that, that's a furnace fails to operate, and what it could be locked out due to excessive retries, excessive number of retries. And then we look at all the things that could cause that and that we need to look at. And some things might be a little, stand out a little more than others, but you have to go through those to see what's going on. And down here we see that to view a clear fault codes, that's in the manual. All of this, a lot of this is in the manual. Well, all of these pages like this, but to clear the fault codes, just go in and do what that tells you, and you can clear the fault codes. And as we said before, this is the sequence of operations heating mode for the G or the AR9T96 2-stage non-communicating R32 ready furnace. Upon being powered up, the control board will perform internal and polarity checks. The control will display idle, no call, until a call for the thermostat is received. On a call for heat, the thermostat contacts close and send 24-volt a 24-volt AC signal to the W1 terminal on the control board. The control board microcomputer begins its self-check routine. If nothing happens, is the 7-segment LED boards on? Do you see idle or something here on those? If no, then check for 24 volts AC at R and C. If you had 0 volts, check the line voltage to the unit. And you see checking line voltage, it's from, you have to have, have your door switch, something over your door switch, magnetic stud finder, or however you do it. And check the voltage at line N and line H. And here's line H and here's line N, the neutral. And if we have voltage there, well, is there 120 there? If no, there is a board issue because, you've got to, if you have to go back to your, if you check the voltage there, I mean, the door switch is closed, then, you're going to have to go back and look through whatever the problem is. But you're going to chase your power. You're going to have to chase your power backwards. Is it just a faulty door switch? Who knows? But let's move forward. So then if we check over here on the transformer and we don't have power or we do have power, and I'm sorry I fast forwarded past that by accident. It won't let me go back. So then we would check the inlet of our transformer and do we have 120? If we do, then we come over here and check the outlet side and we don't have it. It's a faulty transformer. If there is voltage at R and C, then check voltage at W and C. If you have 0 volts, the problem is the thermostat or the T-stat wire. Because if you have power at R and C, now the power is at that transformer. At that thermostat. So you have power there on the red wire sitting there waiting for the contacts to close, but you don't have power coming down to your furnace. There's a problem with either the thermostat or the thermostat wire. Removing the thermostat wires and jumping R and W on the control board is a quick way of isolating the furnace from the thermostat and the wires. If the unit lights, the problem is either the thermostat wires or the thermostat itself. Because if you're taking the thermostat and the wires out of this situation and jumping straight from the board and the unit runs, there's nothing wrong with the furnace. The problem is the wires or the thermostat itself, or it's thermostat sub base, but it's outside of the furnace. The control verifies the auxiliary switches, and the primary limit switch is closed by sending out 24 volts on pin 1, a pink wire of the 12-pin connector through the auxiliary limits on the primary limit and back down to the red terminal, as we're going to see here. Pin 8 on the 12-pin connector. And here we see our 1 and our 8 coming out of this pin connector. And the 7-segment LED board will alternate between GH1, first stage heat, and FO1, default first stage heat, airflow speed. There are options to change the heating speed and or make the furnace fire on high fire at all times. Just like there's options to make it run different times in single stage, first stage, so that you get better air mixing and all that. The 24-volt split at the primary limit control and travels on the purple wire up to the inlet side of the first rollout switch, changes to a pink wire, and goes over to the second rollout switch. It then travels from the outlet of the second rollout switch on a purple wire down to the number 12 pin on your 12-pin connector, proving the rollouts are closed. And you see here, it's from the 1, we would test that, and from the 12. If any one of the safety switches were open, the unit will flash one of the error codes below, and it's open high limit or open rollout switch. And remember, whenever you have an open switch like that, the fan's going to run all the time. So we know that, and so the primary limit switch and the auxiliary switches are automatic reset switches and should not be open. As we see here, it's our rollouts. Here's our primary limit, and the auxiliary limits are in the blower housing. The Daikin Goodman Manor is talking of getting rid of those because they now have an amperage monitor on the circulator H. So in the future, it won't be long before there won't be those auxiliary limits on the side of the blower anymore, because a lot of people don't even know they're there. And here we see the auxiliary limits are located up in the back here on the sides, and you see the wires going out to them, this yellow and this red and this purple and this yellow, but they goes back there. And if we look down here, this is the limit on the left side of the blower, and here's the limit on the right side of the blower. Rollout switches are manual reset switches. If open, you will have to push the reset button on the rollout. And of course, we know that why a rollout switch is manual reset is because if a rollout switch is open, somebody qualified needs to go down and look at the furnace and figure out why it's tripping on the rollout. And again, the word qualified. We will go over using your meter to troubleshoot the safety circuit in the last segment of the video. The power splits at the outlet of the second rollout switch and goes up to the inlet side of the low fire pressure switch on an orange wire, and then over to the second stage pressure switch on a yellow wire. This proves the pressure switches are open because the voltage doesn't travel back on the outlet orange wire to pin 5 on the 12-pin connector, or the second stage yellow wire back to the 9-pin on the 12-pin connector. As we see here, that both switches are open. If either pressure switch was stuck closed, you would get the error code from that switch. To ohm out the switch, shut off the power, pull one of the wires off the switch, and that's causing the error code. Set your meter to ohms and apply your probes. But we see here we have a low fire pressure switch is closed. That's going to cause the error switch, low stage pressure switch, stuck closed. The second stage pressure switch is fine. It's open, should be open, and that's good. But because the first stage pressure switch is excuse me, is not open, then we'll get an error code. If you have continuity, the switch is closed. If you have an OL, the switch is open. And to ohm that switch out, you shut off the power, pull one of the wires off, and you know, we've already talked about that. But so we see here that you can also test if a pressure switch is open or closed by doing a simple voltage check. If the unit is operating but not firing. And you're not going to really see that in the startup sequence, but you can always tell if a switch is open or closed by this test. And it can be a limit switch, a pressure switch. Switch closed, no voltage, because remember, there's no potential difference here for the power. And we're not going to go over that because I'm assuming that you know that, but just that there's the same leg of power as you can use that term, no polarity, I mean, no potential difference, you won't see it. Power here, you would get power here though if you took voltage of that switch, because power there uh, is there because there's no potential difference here. I mean, there is potential difference, excuse me. And that's why you see you're going to get 24 volts there. So that's just a little trick to the trade to keep in your toolbox. Because, so again, just for review, switch closed, no voltage. Switch open, voltage. And also you might say, well, how would the wire still on there? Would I be able to get my readings? I didn't put the wires back on here, but you see that little notch right there? And each one of them has it. And, they, even if it's turned this way, but you can just get right you can use those little notches to take your voltage measurements on the pressure switch. A control module performs a gas valve circuitry check. As you see that now, you got power up to your main and your low fire and your high fire. And you won't, because the pressure switch is open here, your front cover pressure switch, no matter what, the valve couldn't open anyway, because remember, a valve, the coiling is a load, and you can't, a load has to have a complete path. That means, from the hot leg all the way through the load and back on the neutral. And because it's open, you don't have that. And if by some chance that front cover press switch was closed, it wouldn't matter because it would trigger an error code. If your front cover pressure switch was closed, it needs to be replaced. Okay. And we see that we would get these internal gas valve error, external gas valve error, one of those. If you was actually reporting that, the gas valve was calling, sending was closed, then it's going to give you those error codes because it shouldn't have that. The power venter motor is energized. We will assume the power venter came on and is running. We will go over testing it later in the video. But so there's our power venter on. And the pre-purge period begins once the low fire pressure switch is detected closed. That's 24 volts on pin 5. The front cover pressure switch will close at this time also. The gas valve uh, common is now closed. If the front cover switch is open, check your hoses for water or kinks or your drains, because we have our front cover pressure switch closed now. So we should be good to go. After completion of the pre-purge, the control will energize the igniter. So now our igniter has been energized. So if the igniter doesn't energize, if the igniter doesn't get hot, is there 120 volts at the terminals? If yes, replace the igniter. If no, replace the board. If the igniter looks like it's getting hot but doesn't like the unit, the silicone nitride igniter has a normal operating temperature of approximately 2,156 degrees Fahrenheit to 2,678 degrees Fahrenheit. At room temperature, the igniter ohm reading should be from 37 to 68 ohms. And here we see that you break this little, you see the igniter right up here in the left-hand corner, and this plug comes down from it. We break this open, as you see here. Then we take the igniter side and we ohm it out with our probes here. We could also see if there's voltage there, do a voltage test after or whatever. But right now we're ohming out the igniter, but you could use this to do a voltage test on it also, run it through another cycle. If the igniter looks like it's getting hot but doesn't light the unit, place the unit in heating cycle, measure current draw of the igniter during preheat cycle. The steady state current at 120 volts is 0.37 to 0.68 amps. If not, replace the igniter. After completion of the igniter warm-up period, the first stage of the gas valve is energized by pin 10 of the 12-pin connector plug and goes to the gas valve low side on a white wire. And yes, that is a grayish wire, but obviously I can't use white on white. It doesn't show up very well. The front cover pressure switch is now closed, allowing a complete circuit to be made from the common on the gas valve to pin 11 in the 12-pin plug, as we see here, 10 and 11. So we have ignition now, and we see that indicated by our flame sensor here. If the gas valve doesn't open, is there voltage at low fire and common on the gas valve? 24 volts at pins 10 and 11 in the 12-pin connector. We see there, we're looking for 24 volts, and we're looking for it here at our pins 10 and 11. But we need to know, do we have voltage there? Because when you hear that click, you're waiting, the igniter's hot, you're waiting, you hear that click, that's the relay closing, and power should be coming out of there. And also, if it's not lighting, is the front cover pressure switch closed? That's the other thing that you need to be looking at. The furnace front cover pressure switch is wired in series with the low main solenoid of the gas valve. In the event of a non-functioning gas valve, always check the front cover pressure switch. Also, see checking pressure switches. gas outlet pressure port. As we see here, most of you are well aware that those are the inlet and the outlet gas pressure ports. They call them pressure bosses. And we have our outlet and our inlet. You're going to use a wrench, a hex wrench. And if you get, when you buy a conversion kit, there's a little kit in there that has one of those little wrenches, and they're hard to find just independently. Always take that kit, and there's an adapter, piece of little tubing and an adapter. You want to keep one of those kits. At least keep it right in your manometer or your if you use a spring pressure gauge, like from a long time ago. I mean, they all work, but keep that little hex head wrench in there because that's a difficult size to find. And you're going to verify that inlet and outlet gas pressure. And here's just showing, what your pressure should be, for manifold pressure and your inlet gas supply. Natural, you want like 4.5 anyway incoming because you're going to need 3.5 overall, and maximum of 10. And your propane inlet 11, max 13. And then just shows here your low fires and your high fires for your gas valves. Natural nominal is 1.9 on low stage and 3.5 on high stage, and the nominal is 6 inches of water column on low stage and 10 inches of water column on the high stage. And we see here we're hooked up to our outlet pressure boss here, our inlet pressure boss here to see what we got. And if you have a dual port manometer, you can check them both at the same time. And another step is, and this is not so much a startup, although it could be if the units ran a summer in a really humid basement or something. Could be, and then, but most likely, but I just wanted to show you this just to let you know that if that furnace is doing everything but staying lit or one burner's lighting, in a lot of cases, none of them will when they're crapped up like this. Pull a burner out and the one closest to the igniter and see if the crossover ports on that are all gummed up like this one is. It might save yourself a lot of trouble. I know it's 4 screws taking the manifold off, but if you're sending, if you're sending gas up there and you hear the gas, but it won't light, or one burner lights or something like that, but it doesn't cross over to the next one or something, you're plugged up. And you're going to have to clean up them burners and, best you can until you get the new ones. If you can't get the new ones right that day or something, because, usually you find that in the winter time or something like that. And, you don't have, people want their heat. And checking the gas valve, it's a redundant gas valve, means if one side fails, the other does. If one side doesn't fail, but the other side has a problem, it's going to fail, and then the gas valve isn't going to work. And that provides control of the main burner gas flow, the pressure regulation, and 100% safety shutoff. And the main side of the valve is always energized. When you go to high fire, the main side stays, has power to it because that has to stay open. And the high fire will have voltage to it also. And, you would measure those main to common, high to common. But it's like the old, if you've been around for a while, the thermocouple type furnaces, that the thermocouple always had to have flame on it because that held the main gas valve open. And if that portion of it wasn't open, the rest of the valve wouldn't work either. And if there is no voltage at main and C, the valve won't open. If the second stage valve, if no voltage at main and C and voltage at high and C, the valve won't open. The igniter is de-energized as soon as the flame is sensed. After 30 seconds, the indoor blower motor is energized on first stage heating speed. The blower motor common is just a regular 24-volt common, and we will discuss that in a minute. If the motor doesn't start, remove blower compartment door to gain access to the circulator blower motor and integrated control, ignition control. Check for any obstruction that would keep the fan motor from turning. And obviously we would have the power off. You wouldn't be wanting to try to run a motor or whatever and stick your hand in there. Check wiring. The motor has two wiring harnesses, a main harness and a control. And we see here we have our main and we have our control harness. The main pin harness has black wire connected to the Circ H terminal on the control board. And this is what I was telling you about here is that little amp monitor that's going to take the replace of auxiliary limits, because if the motor's not running, it wouldn't read any amperage, and therefore the control would know to shut the unit off. The white neutral wire connected to the Circ N terminal on the control board here. Red wire connected to the COM terminal, which is a female spade connection next to the T1 through 5. Excuse me. Here's our T1 through 5, and there's our common is right under it. And the green wire connected to the cabinet ground. And this green wire on the motor is just connected right onto the blower housing. And here's a better view of there's the red wire in that line voltage plug. That's the common for this. And here it is here, where's where it goes on the board. Just another view of there's our motor speed taps here. But this is the red motor speed tap. This is the common. And we have blue wire to T1, red wire T2, orange wire T3, black wire T4, and yellow wire T5. And of course, those are on the control board right here. And you can measure these voltages off the side of this. So the multi-speed ECM motor requires a line voltage power supply, black connected to the Circ H and white connected to the Circ N, neutral on the control board, and as well as a signal on one of the speed taps, T1 through T5. The speed tap voltage is 6 to 17 volts DC and can vary depending on speed selection. The voltage reading from any one of the speed taps is referenced between the female common terminal next to the speed taps on the control board. And that's right here. And also, this is just showing you what your speeds are and what, taps that should see. And remember, it's not always going to be 17 volts. It can be as low as 6. But here it's showing you a good example is 9. It's easy to see here on this. On 1 and 5 are on. But the X's on here means that the tap can be either on or off. So, just keep that in mind. When using a single stage heating thermostat, the furnace will transition to second stage gas heat by either a fixed time or auto mode, depending on the menu selections made by the installer. So just remember that. I mean, Um, if I was in the field, I mean, I have one of these. I have the previous generation of this. So mine, you can only set it for up to 20 minutes, but I have mine set so that it can't go to high fire in the first 20 minutes because I like that, you know, my furnace is, is right sized, my right soft, load calculation and stuff. So I want to get the maximum amount of time of my unit running to mix the air instead of just having, you know, uh, a big, a right sized or oversized, but yet it comes on full tilt boogie and, just dumps a bunch of heat into the room. And then you have air stratification, you have those hot and warm pockets and, it's just uncomfortable. So, if you're using, these are a great furnace to use. And I mean, you can set them up to an hour now to fire on low stage for up to an hour. Maybe you wouldn't want to go that far, but 30 or 40 minutes, if mine had it, I would certainly do it. And the inducer motor is enabled at high speed, closing the second stage pressure switch and allowing the 24 volts to travel down the yellow wire uh, to pin 9 and on the 12-pin connector, confirming the second stage gas valve is closed. This will energize the high fire stage. Um, and the gas heat speed of the indoor blower motor is energized. So now we get that higher speed airflow that we need. And again, up here, just these are our default speeds, and these are speeds that we can also use depending on what we're doing and all of that. Call for second stage heat when using a two-stage thermostat, a true two-stage, where you know that you have to go into the thermostat and set the differential then. Um, but whether you like 1 degree, most of them go 1 to like 3.5, something like that. 5 is a lot, but then again, you never know. That is might just make it run longer, but finally it would get to it. But 1 to 3 is okay. I would want it to run longer on one stage. As I just told you, I'm a big proponent of letting that run 20, 30 minutes. I mean, you're running at half the BTUs, and on real cold days, it's already caught up. So, it's not gonna like uh, freeze you out. And if it does, it's just, we'll go to second stage. Shutdown sequence. When the thermostat satisfies, reaches the set point, the call on W1, W2, if applicable, will be removed. The gas valve is de-energized and the burners go out. The inducer remains on for the post-purge period of 15 seconds. As the inducer shuts down, the pressure switches will open. The indoor blower runs for the selected off delay period, 90 seconds by default, but is adjustable from 30 to 180 seconds. And you want to get that, you don't want to go too long, but you want to get that residual heat off the uh, furnace also. Troubleshooting safety circuits on the AR9T96 and GR. Sorry about that. I thought I wasn't recording. GR9T96 R32 ready, two-stage non-communicating furnace. So safety circuits serve to control any potential safety hazards and are in place to ensure proper furnace operation. The safety circuits in this furnace serve as inputs to the control board for continuous monitoring and for diagnosing abnormal furnace functions. Safety circuits include auxiliary limit control, which is an auto reset, primary limit control, which is an auto reset, rollout limit control, manual reset, low fire pressure switch, high fire pressure switch, and front cover pressure switch. And here we're just making the point about the 12-pin plug. You want to locate that. Make sure your numbers are correct. And on the board here, you look down the side of it and you'll see these numbers, and that's the orientation of your plug. So just remember that whenever you're testing something, you want to be sure you have that orientation of the plug right. Because the plug only fits in one way, but that doesn't mean you can't flip it or have it wrong in your hand. They haven't published a ladder diagram for this unit yet, but if you have the pictorial and ladder diagrams, you can use these numbers to figure out the pin numbers, because all of these numbers right here are one of these wires in the 12 pin, in this case 15 pin plug, but in this furnace actually it only has 12, but this is from another furnace just so I could show you that those numbers, are one of the pins, and each one of these numbers is a pin in the plug. Testing the entire safety circuit to rule out a limit issue. Limit switches are normally closed and open on a rise in temperature. Limit switches can be tested individually, or the entire series safety circuit can be tested and ruled out of the problem. Turn off the power to the furnace. Remove the 12-pin connector from the board. And again, make sure you know what plugs are what. Review diagram and locate the wires that exit and then re-enter the 12-pin connector from the board. Orientate your pin locations. So we know pin 1 and pin 8. To pin 8, we can ohm out our 2 auxiliary limits and our primary limit. And that we see here in our plug. 1 and 8, 1 and 8, up and over. Now, that's if you're only doing the primary and auxiliary limit test. You can also see that going up and through the other 2 limits, your roll-up switches, and going back to that pin 12, you can see that if all of them are open or all are closed, you'll see if one's open or they're all closed, and you can do that in one fell swoop. The only thing is you got to start checking individual ones if you do have an open one. But to test 1 to 8, if you pass that, that tells you that you don't need to check those ones. You need to check your rollouts. Because 1 to 8, if all of those are closed, and then you would just go 1 to 12 to finish it off, and you would find that your rollouts, press your rollouts, the unit comes back on, but you still need to figure out why it went out on a rollout. Troubleshooting limit switches, testing a single limit switch. Remove at least one of the low voltage wires at the limit control switch. Set meter to ohms and test between both terminals. Ohms should be continuous unless the heat exchanger temperature is above the limit control setting. Testing the power venter motor. The power venter motor is energized. When the time comes for the vent motor to be energized, but it doesn't come on, we will have to figure out why. But in this case, we're going to assume that it did work. Well, I guess we're not. remove the burner compartment door, gain access to the inducer draft blower motor, disconnect the motor wire leads from its connection point at the included draft motor. And here's that plug right there in the furnace. And we take that and we separate it, as you see here. And we use an ohm meter to test for continuity between each of the motor leads. We see here. And all three of them, we have continuity. And if we didn't have the continuity between the three, you'd change the motor. Touch one probe of the ohm meter to the motor frame, ground, and the other probe in turn to each lead. So we would have the black. You always want to use your black for neutral or ground if possible. And just they always recommend that, you know. So you're just gonna hold that to that ground and test each pin and see if you have continuity to ground, and you shouldn't. If you do, you need to replace the motor. If the windings checks are good, reconnect wires, turn power on to the furnace, and turn the thermostat on in the heating mode. Check the voltage for 120 volts at AC at the induced draft motor terminals during the trial for ignition. Oh, it's not going to let me go back. But you should have that power. And if you don't, well, it's a board issue. It's not putting the power out. If you do, it's the motor. So both of these furnaces have the same pressure switch setup: left to right, low fire pressure switch, high fire pressure switch, and front cover pressure switch. So troubleshooting them, the pressure switches are safety devices used to prevent inadequate venting caused by restricted or blocked vent pipe. And the AOG R9T96 furnace also has a front cover pressure switch wired in series with the gas valve. When the switch is open, the gas valve cannot open. The front cover pressure switch keeps the gas valve from opening in the event of condensate backing up in the secondary heat exchanger. And we see that this is, you want to keep your hoses nice and straight and downward flow all the time, no loops or dips, because that's where on the off cycle, water vapor can get in the tubing, condense down, and then plug that dip. Backup could occur from an improperly connected drain line or a plugged drain. That's why you always want to go through your tubes and make sure there's no excess, and things aren't pitched or have dips in them or anything like that. Troubleshooting pressure switches. Here you see that you can remove the wire from the terminals and control hose from the pressure switch to be tested, and you set it up so that you're putting your manometer in line, because that vacuum is measured in inches of water column also. And if you have one of the UEI kits that has one of these pressure little four-way, little T, and also has pressure tips and tubing in it, but we're talking about checking the pressure, vacuum pressure on the pressure switches right now. These T's work well too. I use both. But anyway, you want to put your manometer in line. That's what you're doing with this, so that the vacuum switch still gets its vacuum, but you can monitor the vacuum also. And, and you're just hooking it up in that manner. Here's one where this is to the inducer here. There's our vacuum hose going straight over to where the inducer should connect to this. And then We've got our little T in there so that we can use our manometer with it. Same here. We're into the front cover pressure switch now, and we just put the tube in there. We're breaking it, putting our T. We've got our manometer here, another piece of tube running down to our front cover pressure, our front cover, where we would measure that vacuum pressure. When induced draft motor starts, take ohm readings on pressure switch terminals, just like you would normal. If you left everything hooked up and wasn't trying to monitor the inches of water column reading. Switch should close and meter should show a complete across the pressure switch. So, okay. And this number on the pressure switch, that's the number the pressure switch will close at. Anything less than that, it will open at. But you should have 10 to 20% more vacuum pressure at that pressure switch. And if everything's operating correctly, you would see that. And if the switch doesn't close, compare it to that to see, what you have versus what it needs. The amount of vacuum needed to close the vacuum pressure switch must be greater than the number on the switch nameplate. And as I said earlier, the 10 to 20% more, in fact. The second stage pressure switch obviously has the highest vacuum pressure requirement. And the first stage next, and the lowest is the front cover. And those are usually about just a negative 0.10, not much vacuum pressure at all required. That's all, folks. Thanks for watching the video. If you like the video, please give us a like and subscribe to our channel so that you don't miss any videos upcoming. Thanks again for watching. There's our channel address.